Okay, so I'd like to go through the warm-up that we never had a chance to do in class on power functions, because I think this will help you understand and help find patterns in the coefficient for b, because that's your goal for Friday when you do your exploration. So if you recall, this was the warm-up, and this warm-up is 3 different problems. Each is a negative integer raised to a fractional exponent. And so when we think about exponentiation, normally we think of exponentiation here as just repeated multiplication. So if we had something like negative 2 to the 3rd power, we interpret that to be negative 2 multiplied by itself 3 times. It's a pretty straightforward definition. It gets more interesting, though, when there's fractional exponents here, because what does it mean to multiply negative 2 3/8 of a time, right? We can't really easily express it in this form here. It's not really repeated multiplication. So I want to go through each one of these to talk about what's going on here. The first thing what might be interesting is to put it in the calculator. And so what I did is I actually punched these 3 into the calculator to see what the result was and screenshot it right here. And so isn't this interesting? We have three different calculations. The first one says error, non-real calculation. The second one gives us a number, but notice how the number is negative. And then the third one here gives us a number, but notice how the number is actually a positive number. So the question is, why do these 3 seemingly similar looking expressions give us some different outcomes like this? We get one that says doesn't exist, negative, and positive. So that's what I want to focus on for this warm-up, is what's going on here with each of these 3 things. Well, because we think of exponentiation as repeated multiplication, the trick here is to really re-express these things in ways that allow us to think about it as true repeated multiplication. So the way I'd like to do that is I'm going to rewrite this top one here as negative 2, using the powers of exponents that we know, to the 1/8 power, all raised to the 3. And you know, if we wanted to resimplify this, when you have a power raised to a power, remember those multiplies, so we would just get 1/8 times 3 to get back to 3/8. And now we can think of this expression as repeated multiplication. It's whatever the value of this thing is multiplied by itself 3 times. So the next question then is, well, what is negative 2 to the 1/8 power? Well, this is definitionally, hopefully this is review, but the way that this fractional exponent is defined, it's really the 8th root of negative 2. So it would be whatever number it takes to multiply 8 times to get negative 2. Well, just like the square root of negative 2 doesn't exist, because we can't take 2 numbers, multiply them together, and get a negative 2. We can't find a number where we multiply it 8 times and get a negative number, right? And if we pick a positive number and multiply it 8 times in a row, we'll get a positive number. If we take a negative number and multiply it 8 times by itself, we'll also get a positive number. So we're never going to get this. This thing just does not exist. And so that's why this calculation gave us, you know, no real answer, because when we think about it this way, that core 8th root of negative 2 just didn't exist. So let's rewrite this one in another similar way. So again, this is, you can kind of almost think of this, you can see where this is going with the power function. This would be x, and that 3/8 would be b. And remember, the power function is of the form y equals x to the b. It's just that we're looking at a specific calculation here. All right, so let's look at this one. Negative 2 raised to the 3/7 power. Well, again, let's express this in a way that is reflective of repeated multiplication. And we're going to do that same kind of thing. We're going to rewrite this as negative 2 all raised to the 1/7 power, multiplied 3 times. And again, if you use your rules of exponents, and you'd get back to that starting point. Now here, you know, we can think of it as we're going to multiply this thing by itself 3 times to get that value. And now it's a matter of questioning what does negative 2 to the 1/7 mean. Sorry, I'm just looking up here and realize I didn't write 1/8 here. So negative 2 to the 1/7 power is another way of writing the 7th root of negative 2. And now this case, we want to find some number where we can multiply it by itself 7 times and get a negative number. Well, because this is odd, that thing's going to exist, right? We can find some number that will multiply 7 times itself, and because it's odd, every set of 2 will cancel out to get a positive, and that last one will exist. So this thing is going to exist, and then therefore, once we know that, we can go ahead and raise it to the 3rd power. And this is not easily done in our head, but we can go back and look at the calculator screen here, and it was negative 1.3459. So here for the second one, now we can see why the number in fact exists, and we can see why it's in fact a negative number, because it's this negative number. And when we have a negative number, we know that this negative 2 to the 1/7 will be negative. And when we take a negative number and multiply it by itself 3 times, that's going to give us the fact that this is a negative number. Okay, now let's do the same analysis on this last one here. I'm going to rewrite this as negative 2 to the 1/7, now raised to the 4th power. Well, our first step in the analysis is the same as the last problem. This negative 2 to the 1/7, we know it exists, kind of back right up here, and we know that it's also negative, right? If we're going to pick a number that's multiplied 7 times in a row, it's going to be a negative number, so we know that number is negative. Now here, this was odd before, up on this last one. This one here, we have an even number. So we have whatever number this thing is whatever value this negative 2 to the 1/7, the 7th root of negative 2 is a negative number. Now we're going to think about that as repeated multiplication 4 times. And again, if we have a negative number and multiply it by itself 4 times, that's going to turn into a positive number. And so that's why we know this one exists and it's positive. So hopefully this little warm-up will give you some clues about some of the patterns, especially when we think about the power function with fractional exponents. And maybe just to recap what's going on here up on top. If we have a negative number, I'll call it raised to the a over b, where we express this as a fraction, that b we're going to think of that as the bth root when we rewrite this, right? If you think about all these examples, that's really what we're doing here. Well, if the bth root is even, we're going to get a situation where it just doesn't exist, because there's no number that multiplies an even number of times to get a negative number. If it's odd, that thing will exist. So after we know whether it exists or not, then we can come to this coefficient to decide whether it's going to be a positive number or a negative number. We know if the thing exists. We know if the bth root of negative 2 exists, we know it's going to be negative. And then we look to this fraction, or this number of the fraction, the numerator, to decide whether the overall result will be positive or negative. And here's where we saw if it's even, it's positive, because we're going to multiply a negative number by itself an even number of times. And if this was odd, we would get a negative outcome. So again, my contention is that if you think about what's going on with these 3 examples, you'll be able to also explain what's going on with the behavior of the graph of the power function kind of on this side of the graph, because when you put negative numbers in, we want to figure out what happens. It either disappears like this one, it either goes negative like this one, or it is positive like this one.